Adjunct Professor Moran, Microeconomics 112. In our last session, we explored calculating average costs and using the marginal revenue, marginal cost approach to determine profit maximization compared to using the total revenue, total cost approach. In this session, we're going to practice calculating those numbers. We demonstrated them in our last video. Now we're going to practice calculating them, which we've done in the prior unit on costs, and we're going to graph them. Then we're going to answer some questions, get a review about costs from a prior session, and we're going to generalize about the shape of these cost curves once we've graphed them, so we can use them for both profit maximization and loss minimization and shutting down scenarios. Okay. So to calculate average total cost, we need to know, we have variable cost provided, we need to know what fixed cost is. Fixed cost, total fixed cost equals total cost at zero quantity of output, because there's no variable cost at zero outputs. The only cost you have is fixed cost. So this 12 is your total fixed cost. Adding 12, fixed cost, which doesn't change with the quantity of output, will give you your total cost. So 12 plus 4 is 16, 12 plus 7 is 19, 12, 21, 12, 24. 12 and 18 is 30. 12 and 27 is 39. 12 and 37 is 49. 61. 12 and 63 is 75. 12 and 79 is 91. Total variable cost plus total fixed cost, which is constant at 12, gives us our total cost. Our marginal cost is the change in total cost divided by the change in output. Now notice these changes in output are 1, but if these were 10, you would have to divide this change by 10. In this problem, also notice that marginal, this caret, indicates that marginal is a change measure. You need information from two lines. Notice later when we calculate averages, all the information for an average comes off one line. It's a snapshot, as opposed to a change measure like marginal. So at 1 unit of output, we have total cost of 16. At no units of output, we have total cost of 12. Our marginal cost is 4. 2, total cost 19. 1, total cost of 16. Marginal cost of 3. 21 compared to 9 is 2. 24 compared to 1 is 3. 30 compared to 24 gives us a marginal cost of 6, marginal cost of 9, marginal cost of 10, marginal cost of 12, 14, and 16. Average total cost can be found by adding average fixed cost to average variable cost. So you take 12 and divide it by quantity of output, or you can take your total cost and divide it by quantity of output. 16 divided by 1 is 16, 19 divided by 2 is 950, 21 divided by 3 is 7, 24 divided by 4 is 6, 30 divided by 5 is also 6, 39 divided by 6 is 6 and a half, it's 50, we'll say 650, 49 divided by 7 is 7, 61 divided by 8 is 7.6, 75 divided by 9 is 830, and 91 divided by 10 is $9.10. Why is variable cost? Now let's calculate average variable cost. Okay, so 4, you take the total variable cost divided by quantity of output. 4 divided by 1 is 4. 7 divided by 2 is 350. 9 divided by 3 is 3. 12 divided by 4 is also 3. 18 divided by 5 is 3.6. 27 divided by 6 is 4.5. 37 divided by 7 is 5.3. 49 divided by 8 is 610. 63 divided by 9 is 7. And 79 divided by 10 is $7.90. So we just calculated our marginal cost, our total cost, our average cost. Now we can start graphing our costs, our cost curve. Our goal here is to graph these cost curves and find the intersections that result in either profit maximization, loss minimization, or shutting down. So we can do it from a numeric table. Or we can do it from the graphs. So, we're not going to calculate average fixed because average fixed is not changeable in the short run. So we're only going to calculate our average total and our average variable. Then we're going to compare average total and average variable, which are on a per unit basis, to price and determine whether we're profit maximizing, loss minimizing, or shutting down. Okay, so 16 and 1. 16 and 1, 950 and 2, 7 and 3. So we're graphing the average total cost curve, 6 and 4, 6 and 5, 6 and a half, 7, 7 and 7. Interesting. 7.6 and 8. 8.3 and 9. And 7.9. 9.1. 9.1. Okay, we connect the dots. And we have an average total cost curve. Now we're going to calculate. Now we're going to graph our average variable cost curve. We're just done. Now we're going to do average variable. Then we're going to do marginal cost. Average variable. 4 and 1. 350 and 2. 3, 3, 3.6, 4.5, 5.3, 6.1, 7. Ooh, I missed one. 7.9. 7, 5.3, 5. Okay, so now we have an average variable cost curve. Average variable cost. Now we can graph our marginal cost curve. 1 and 4. 2 units is 3. 3 units is 2. 4 units is 3. 4 units is 3, yes. 5 units, 3.6. 5 units is 6. 6. Here we go. 6 units is 9. 10, 12, 14, 16. Okay, here's our marginal cost curve. Alright. So, how would you interpret the vertical distance between average total cost and average variable cost? This gap is what they're talking about, which varies, and that's your average fixed cost. So average fixed cost is not explicitly on this graph, but if you take average total cost and subtract average variable cost, you get average fixed cost. Notice that average fixed cost declines with increasing output, as increasing output requires each one to share less of the total fixed cost, which doesn't change with changes in output. So each one is now carrying less of a burden, and so this gap gets smaller. So although not explicitly on here, you should be able to calculate fixed costs from the curves provided. Why does average total cost decline at first and then start rising? In the short run, the answer to all of life's questions is the principle of diminishing marginal returns. You have increasing marginal returns, then diminishing marginal returns, and eventually negative marginal returns. The marginal cost curve intersects both average cost curves at their minimum. So this is average variable cost min, and this is average total cost min. And that's because as long as the marginal cost is below the average, even if marginal cost is rising, the average will fall. But once marginal cost is above average variable cost, it's going to bring it up with it. Average total cost, similarly, as long as marginal cost is below average, even if marginal cost is rising, average will fall. But once marginal cost rises above, it's going to drag average total with it. Why does average variable cost minimize before average total cost does? Because average total cost also includes average fixed, so it takes it longer to react because of the fixed cost. If fixed costs were 20 instead of 12, how would the change affect average variable cost and marginal cost? Average variable cost would rise. Average total cost would not change. Alright, so now we have practice graphing these, and what you need to do is you need to be able to freehand this repeatedly. So this is price and cost, and this is going to be quantity of output. Now, you're going to draw a marginal cost curve which looks like a check mark. An average variable cost, which minimizes there and goes up, and an average total cost curve, which is a wider gap at first and then a narrower gap. Average total cost. Whoops, sorry about that. Okay, this looks complicated, but really all you're doing is drawing a check mark for marginal cost, a saucer, average variable cost, another saucer above that, which is a little more tippy, average total cost, and those are your three curves. So you should practice freehanding this, because we're going to be doing a lot of that in this chapter on pure competition, the next chapter on monopolistic monopoly, and the next chapter on monopolistic competition and monopoly. Okay, in our next session we're going to use these graphs to demonstrate our price quantity determination rule of marginal cost marginal revenue approach, using averages to determine price quantity determination for a purely competitive firm.